Hello, my dear students. I am Dr. Dharmendra Tyagi, working as an associate professor in Mechanical Engineering Department, SIRT, the SAGE Group Bhopal. Today, we are going to discuss about the Ocean Thermal Energy Conversion, that is OTEC. Now, the Ocean Thermal Energy Conversion is a technology for generating the renewable energy that uses the temperature difference between the deep cold water and relatively warmer surface water of the ocean to generate the base load electricity. This is also called the principle of the OTEC, Ocean Thermal Energy Conversion. And it uses the temperature difference which is greater than or equals to 20 degrees centigrade. Temperature difference, that it means the temperature difference between the deep cold water and the warmer surface water, that is which is equals greater than or equals to 20 degrees centigrade. And it requires the large volume of both warm and cold water to generate the electricity. Now, for example, 100 megawatt OTEC facility would likely require 10 to 20 billion of gallons of water per day. This is the huge amount of the water is required to produce the 100 megawatt electricity. And the cold water at a depth of approximately 1000 meters or 1 to 2 kilometers. To accommodate the large cold water flow, the size of the pipe for a 100 megawatt facility may be approximately 10 meters in diameter. Now, there are types of a OTEC system. The types of a OTEC system, there are 5 types of the OTEC system. These are closed cycle system, open cycle system, modified open cycle system, hybrid hybrid OTEC system, thermoelectric OTEC system. In this case, we will discuss only two. First one is closed cycle system and second one is the open cycle system. And the closed cycle system, it is also called the Anderson cycle system or vapor cycle system. And the open cycle system, which is also called the closed cycle system and steam cycle system. So now we will discuss one by one these two cycles, that is the closed cycle system and open cycle system. So now the closed cycle OTEC system, Ocean Thermal Energy Conversion System. So this is the schematic diagram of closed cycle OTEC system. Here you can see the temperature difference, which is equals to 20 degree. Here the warm water temperature is 25 degree and the cold water temperature is 5 degree. The difference is 20 degree. Now this is the evaporator, this is the vapor turbine, and this component is condenser, and this is the pump, or we can say that the ammonia pump. So here first you can see the warm water is taken from the ocean surface in the evaporator to evaporate the ammonia fluid, and this ammonia is evaporated and converted into the vapor. This vapor is circulated to the vapor turbine, and the vapor turbine is coupled with the generator to produce the electricity. And the exhaust vapor is coming out from the turbine is condensed by the condenser, and the water is taken from the depth of the sea in the condenser, which is cold water. And the condensate is coming from the condenser is coming back to the evaporator, and cycle is continue. Then this is the closed cycle system, and here you can see the closed cycle ocean thermal energy conversion system use a working fluid with a low boiling point, that is ammonia, and use it to power a turbine to generate the electricity. And warm seawater is taken in the form from the surface of the ocean and cold water from the depth. The warm seawater vaporizes the fluid in the heat exchanger and turning the generator to produce the electricity. The fluid now in vapor state is brought in the contact with cold water, which turns it back into a liquid. The fluid is recycled in the system. That is why it is called a closed cycle system. So we have already discussed this in the with the help of diagram also. Now coming into the open cycle system. Here you can see that this is the diagram of open cycle system. In this diagram, you can see this is the flash evaporator, and this is the pump for the taking the water from ocean surface, and this is the vacuum pump. This is the separator. This is the steam turbine because it is also called a steam cycle system, and this is the generator, and this is condenser, and the cold water coming from the depth of the ocean, which is required in the condenser for condensing the exhaust steam, and this water is reinjected back to the ocean. And we'll start the working of this open cycle OTEC system. So here you can see that first we'll take the ocean surface water, which is temperature is around 25 degrees centigrade, to the flash evaporator, and the function of the flash evaporator is to done the partial evaporation, and here the some steam and some of the liquid particles are there. So there is one separator is also used for to separate the steam and liquid particles and liquid water. That the liquid water is injected back to the ocean, and the steam is used to run the turbine. So this is the steam turbine. So this turbine is to connected with the generator to produce the electricity, and the exhausted steam coming out from this turbine is condensed by the condenser with the help of water and with the help of the cold water. The cold water is coming from the ocean depth, and this water is re-injected back to the ocean or sea. And this is the simple basic working of open cycle OTEC system. Here only vacuum pump is also used to remove the non-condensable gases from this flash evaporator. So now the open cycle OTEC directly uses the warm water from the surface to make electricity. The warm seawater is first pumped into a low pressure chamber where it undergoes a drop in boiling point due to the pressure drop. This causes the water to boil. This steam drives a low pressure turbine which is attached to an electrical generator to produce the electricity. Now some of the advantages of OTEC system. It is a clean form of energy conversion, or we can say that it is the renewable energy source, and it does not occupy land area, no fuel cost as compared to the steam power plant, pollution free, and power from OTC is continuous and renewable. Some of the limitations of OTEC plant: about 30% of power generated would be used to pump water. The system would have to withstand the strong convective effect of seawater, hurricanes, and presence of debris and fish contribute additional hazard. The materials used will have to withstand the highly corrosive atmosphere and working fluid. Construction of a floating plant or power plant is very difficult. Plant size is limited to about 100 megawatt due to the large size of components. Very heavy investment is required initially. Now, the application of OTEs. A closed cycle OTEC plant can also act as a chemical treatment plant. The closing area of OTEC can be used for adequate aquaculture and mariculture. The deep ocean cold water is rich in nutrients and can be used for various applications. OTAC plant are quite suitable for the co-generation of electricity and fresh water. Now you can see the development of OTC plant. In 1979, the first OTEC plant was installed in the Hawaii state of US. It was a prototype 50 kilowatt floating plant operated on a closed Rankine cycle principle with NS3 as the working fluid. It was designed with the ocean water temperature difference of around 21 degrees centigrade. The net power available was only 15 kilowatt as 35 kilowatt was consumed in the pumping the warm and cold water. Another plant was installed in Nauru, Japan in the Central Pacific Ocean. It was an on-land plant and was economical in construction. It required a 945-meter pipeline for pumping cold water. Its gross power capacity was 100 kilowatt, operated with a seawater temperature difference of 21.7 degrees centigrade. The output power was 31.5 kilowatt. The turbine used was an axial flow type with 3000 RPM. The generator was directly coupled and supplied power at 415 volt and 50 hertz. But in India, the National Institute of Ocean Technology is implementing the world's first megawatt floating OTEC technology demonstration project of the Tuticorin coast in Tamil Nadu. The various subsystems for the plant have been configured, designed, and integrated on an OTEC floating vast. A 1 kilometer long cold water pipe has been towed to the site and deployed vertically with an anchoring the system at a depth of 1.2 kilometer. The resource potential of India is estimated around 180 into 10 to the power 3 megawatt. Now the efficiency of OTEC plant. The maximum efficiency of a heat engine working between the two temperature limit cannot be more than the Carnot cycle operating between the same temperature limit. The Carnot cycle efficiency is T1 minus T2 upon T1. Here, for example, we can take the temperature of T1 is 27 degrees centigrade and T2 is 5 degrees centigrade. This is the warm water surface water, and this is the cold water at the depth. And it is converted into the Kelvin, that is 300 and 278 Kelvin. Now substitute these values in the equation of efficiency and we will get the efficiency is 7.33%, which is low. But in actual practice, it is only the theoretical value. But in actual practical is about 2% only, which is very low. So this is all about the OTEC system. And we have discussed only the two cycles, closed cycle system and open cycle system. And the next cycle we will discuss in the next lecture. So thank you.